Tonight, you'll hear the true story of a visitor from beyond the stars. A mystery that scientists still struggle to explain, told in a calm rhythm designed to quiet your thoughts. As you listen, you'll not only uncover hidden secrets of Three-Eye Atlas, you'll also drift into deep, peaceful sleep, guaranteed.
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
October 1st, 2025. A date that should have passed like any other in the endless churn of political arguments and budget deadlines. Instead, it became the opening scene of a story that would ripple far beyond the walls of Washington, far beyond the limits of our atmosphere, and into the very heart of cosmic mystery. On that morning, as the United States government stumbled into shutdown, the world's most famous space agency, NASA, posted a single stark message on its website. Due to a lapse in appropriations, operations are limited. Public updates will be paused. And with that, the stream of images, announcements, and real-time discoveries that had long been the soundtrack of space exploration fell silent. It might have been dismissed as political noise, another casualty of legislative gridlock. But the silence was anything but ordinary, because at that very moment, at that precise window in time, an interstellar object, unlike almost anything humanity had ever seen, drifted into our cosmic neighborhood. Astronomers called it Three-Eye Atlas, the third confirmed visitor from beyond our solar system. And in an extraordinary coincidence, its trajectory carried it within observational range of Mars, where orbiters from both NASA and the European Space Agency had front-row seats. The timing was uncanny. As NASA's voice went quiet, the skies delivered one of the rarest opportunities in astronomical history. A fleeting traveler from the stars, seen not from Earth, but from the vantage point of another planet. Think about the odds. For billions of years, comets and asteroids have been confined to the sun's dominion, locked in elliptical paths that keep them tethered to our system. Interstellar visitors are different. They are exiles, objects thrown free from their birth stars by ancient gravitational slingshots, wandering alone through the dark for eons until chance brings them to us. Only two had ever been spotted before. In 2017 came Oumuamua, a strange cigar-shaped body that accelerated in ways that sparked debates about alien technology. In 2019 came Borisov, a more traditional-looking comet, whose presence reassured some that the first discovery had not been an illusion. And now in the summer of 2025 came Atlas. Discovered by the Asteroid Terrestrial Impact Last Alert System Survey in Hawaii on July 1st, it was quickly recognized as hyperbolic, meaning it wasn't bound to the sun. This was no local object. It was passing through on a one-time trajectory, never to return. By October, its path brought it tantalizingly close to Mars, 30 million kilometers, close enough in astronomical terms to offer a vantage point unlike any before. For the first time, humanity could watch an interstellar visitor from the perspective of another planet. Cameras and spectrometers aboard Mars Express, the ExoMars Trace Gas Orbiter, and NASA's Mars Reconnaissance Orbiter were theoretically capable of recording data that Earth-bound telescopes could not. The stage was set for a once-in-a-lifetime experiment, and then silence. Not scientific silence, data was still being gathered, spacecraft still operated, instruments still stared into the void, but public silence. Websites froze, press releases halted, social media feeds went blank. The official narrative of one of the most intriguing astronomical events of the decade evaporated into nothing. The timing was so neat, so uncanny, that speculation began immediately. Was this just bad luck? The universe throwing a rare opportunity at us precisely when bureaucracy had tied our hands? Or was the silence convenient? A curtain falling just as something extraordinary approached. To understand why the unease spread so quickly, you need to feel the atmosphere of that first week of October. Amateur astronomers who had tracked Atlas in July and August found it increasingly difficult to observe by September. Its position in the sky had shifted closer to the sun's glare, making ground-based viewing nearly impossible. The geometry meant the best eyes were not on Earth at all, but circling Mars. And those eyes belonged largely to agencies now caught on opposite sides of the silence. ESA pressed ahead openly, announcing its plans to track the object. NASA went dark. The asymmetry was glaring. What made matters worse was history. People remembered the unresolved questions of Oumuamua. They remembered the subtle hints of odd acceleration, the shape that seemed unlike any natural rock, the papers that argued and counter-argued whether it could have been artificial. They remembered Avi Loeb of Harvard publicly suggesting alien origins, and how quickly that debate flared across the media. Now here we were again, with another interstellar body, and the world's most powerful space agency suddenly quiet. The vacuum of information became a breeding ground for suspicion. But let us pause here and ask the more sobering question: what do we actually know about Atlas? At discovery, its coma, its cloud of dust and gas, already suggested activity. That meant it wasn't a dead rock, but a body releasing volatile material as it warmed. The Hubble Space Telescope imaged it in July, constraining its nucleus size to somewhere between a few hundred meters and several kilometers. But the uncertainty was huge. Was it a small dense fragment? A larger but fluffier mass of ice? Without knowing its true size, astronomers couldn't calculate its density. And without density, they couldn't say whether it was ordinary or exotic. The door was open to speculation. A fragment of a shattered world, a comet rich in heavy metals, or even, if you were willing to step into wilder territory, something constructed. In science, uncertainty is oxygen, but in politics it's fire. Within days of the shutdown, online forums lit up with rumors, claims of missing images, suggestions that NASA orbiters had been commanded to observe, but the data was being withheld. Some swore that raw files briefly appeared on servers before vanishing. Others insisted that unusual thruster maneuvers had been detected, unexplained burns hidden in the telemetry. None of it was verifiable, but all of it thrived in the silence, because silence is itself a signal. And when the most powerful voice in space exploration goes quiet during a cosmic event of this magnitude, people will connect the dots, even if those dots were never meant to form a picture. The truth may be less dramatic but no less unsettling. During a government shutdown, NASA is bound by law, the Anti-Deficiency Act, not to spend funds without appropriations. Only activities deemed essential for life and property continue. That means spacecraft safety. That means the International Space Station. But public outreach, press releases, website updates, all of those are furloughed. It isn't a conspiracy, it's policy. Yet the effect is indistinguishable from concealment. The public sees silence at the very moment they crave clarity. And this is where the story takes on its eerie tone. Imagine sitting at home in early October, aware that 30 million kilometers away, alien dust and gas are passing within range of human machines. Imagine knowing that those machines are awake, their sensors gathering photons that have traveled from an object born in another star system. And then imagine that the agencies you look to for discovery say nothing. No images, no graphs, no words, just the dead weight of bureaucracy. Coincidence? Perhaps. But history, is littered with moments where silence wasn't accidental, where the gaps in the record told a story louder than the words themselves. People wondered, was the shutdown just bad timing, or was it the perfect cover? The reality is that answers would take time. Even in normal operations, data from Mars isn't instant. Observations are scheduled, transmitted, calibrated, processed, checked, and eventually published. That pipeline can take weeks or months. Add a shutdown, and the delay becomes longer. But delay in the midst of mystery feels like denial. And so into the void of information, speculation rushed like air into a vacuum. By the end of that week, the lines had been drawn. ESA had confirmed its campaign, explaining to journalists that it was targeting Atlas during its closest pass. Independent observers struggled from Earth, fighting the sun's glare, their reports fragmented and inconclusive. And NASA, its rovers still alive, its orbiters still circling, remained mute. So we return to that haunting image, a cosmic traveler, the third in history, gliding past Mars under watchful but silent eyes, a government shutdown on Earth, a blackout in public communication, 1,000 questions left to ferment in the dark. And as the silence deepened, one question echoed louder than all the others. What exactly was NASA seeing during those days we were not allowed to look? That is where our journey begins. If part one left us standing at the edge of silence, then part two asks us to peer through it. Because while the public heard nothing, the truth is that spacecraft were not blind. The Martian skies in early October 2025 were alive with machines, each carrying sensors and cameras that, if commanded, could have glimpsed the interstellar visitor. To understand the silence, we must first understand the eyes that were open. Orbiting Mars in that first week of October was a small fleet. Silent sentinels with overlapping but distinct capabilities. On the European side was Mars Express, launched in 2003, and still one of the longest-lived planetary orbiters in history. Its high-resolution stereo camera had mapped the Martian surface for decades, but it also had the ability to track faint targets against the blackness of space. Alongside it was the ExoMars Trace Gas Orbiter, bristling with instruments designed to sniff out the invisible signatures of atmospheric molecules, but also equipped with a camera suite and spectrometers that could, under the right circumstances, be turned outward to the stars. On the American side, two orbiters were most relevant. The Mars Reconnaissance Orbiter, carrying the powerful high-rise camera, was capable of extraordinary resolution, down to 30 centimeters per pixel when imaging the surface below. At the comet's distance of 30 million kilometers, high-rise would never resolve surface features, but it could capture brightness, shape hints, and time variations. And then there was MAVEN, the Mars Atmosphere and Volatile Evolution mission, designed to study the planet's upper atmosphere and interaction with solar wind. Its instruments were not built for comet hunting, yet they were sensitive to charged particles and plasma, meaning that if Atlas interacted with the interplanetary environment in unusual ways, MAVEN might catch the whispers. And then, on the surface, the rovers. Perseverance in Jezero Crater, Curiosity still alive in Gale. Neither was designed to track interstellar comets, yet their cameras could be pointed skyward. Even a wide-angle shot, a faint streak across the Martian sky, would have been historic. The first image of an interstellar object taken from the soil of another planet. Whether such commands were ever issued remains unconfirmed. The Europeans were not shy. They openly announced plans to monitor Atlas from October 1st through 7th, explaining to journalists that the geometry was too perfect to waste. The comet AS pass at 30 million kilometers meant Mars would see it from an angle Earth could not, and their spacecraft would have front-row seats. They spoke of measuring the comet's shape, watching its brightness, and teasing out the chemistry of its gases. Their transparency created a contrast so sharp it stung. Europe leaning forward with excitement, America standing still in silence. And yet silence does not mean inaction. NASA's policy during a shutdown is straightforward. Spacecraft operations continue when necessary to protect life and property. That means Mars orbiters did not shut down. Their flight controllers did not abandon them. If thrusters needed firing, they were fired. If instruments needed calibration, they were calibrated. The machines remained alive, but what slipped away was the pipeline of public information. The websites, the press releases, the curated data streams, those stopped. To the outside world, the effect was the same as blindness, but behind the curtain, eyes still watched. Here lies the strange duality. Operational silence is different from informational silence. The spacecraft can be alive, recording, transmitting, and yet the public is left with nothing but a void. This duality is precisely why suspicion grows. Because we know the instruments were there. We know they could have been pointed, and we know that at least in Europe they were. So when America says nothing, the void invites interpretation. Now imagine you are one of the scientists on those missions. You have spent years preparing observation sequences, lobbying for pointing opportunities, planning campaigns for rare events. Suddenly the government shuts down. You are furloughed, legally prohibited from working. Your spacecraft is still out there, circling Mars, still capable of snapping images. But you cannot log in to check. You cannot submit requests. You cannot even confirm whether a pre-approved plan is running. Your silence is not voluntary. It is imposed by law, and the data, if it exists, begins to accumulate somewhere in the deep storage of a spacecraft's memory, waiting to be downlinked when the pipeline reopens. This bureaucratic reality is easy to overlook, but crucial to understand. A scientist is not a free agent. They are bound by systems, and those systems, during a shutdown, become walls. Even if something extraordinary passed before their cameras, the people who would recognize its significance might not even see the files until weeks later. Meanwhile, back on Earth, observers were straining through the sun's glare. The elongation, the angular distance between Atlas and the sun, was painfully small. Observing it from the ground was like trying to see a firefly next to a stadium spotlight. Some professional observatories attempted it, but results were limited. Amateur astronomers tried during twilight, capturing faint streaks, but nothing like the clarity Mars orbiters could provide. And so the eyes on Mars became the key. Now picture the timeline. On October 3rd, Atlas passed closest to Mars. 30 million kilometers. In cosmic terms, practically brushing shoulders. At that distance, HiRISE might not reveal structure, but it could record brightness fluctuations, the fingerprints of shape and rotation. ExoMars's spectrometers could sniff the chemical composition of its coma. Mars Express's stereo camera could map its spread. A fleet of machines designed for other purposes suddenly found themselves at the crossroads of history. Yet in the silence, none of it was visible to the public. Rumors took root. On online forums, people began claiming that NASA orbiters had already taken images that were pulled after being posted briefly. Others argued that oddities in spacecraft telemetry suggested maneuvers not explained in official logs. Still, others whispered about raw FITS files appearing corrupted as though redacted. Whether these claims were true or false, no one could verify. And so the speculation spread like wildfire. This is the psychology of silence. When official channels provide nothing, unofficial voices grow louder. A rumor posted in a forum can sound like evidence when there is nothing to weigh against it. A blurry amateur observation becomes a revelation when no official image is there to provide context. The void is not empty, it is filled with human imagination. And imagination, when mixed with suspicion, is combustible. Yet here is where the cold mathematics of astronomy cuts through. Orbits are not rumors, they are equations. The Minor Planet Center continued to update Atlas's trajectory using observations from before the shutdown. JPL's Solar System Dynamics Group maintained their models. Nothing in those numbers screamed anomaly. The comet was still on its hyperbolic path, still bound for perihelion at the end of October. The orbit itself whispered normalcy, even as the silence around it shouted mystery. Still, the orbit could not answer the deeper questions. What was Atlas made of? How large was its nucleus? Did it behave like a comet, or did it hide something stranger? Those answers would not come from equations alone. They required data, spectra, images, light curves, data locked in orbiters circling Mars, data possibly captured but not yet released. And so the first week of October became a paradox. At the very moment humanity had its best chance to study an interstellar visitor from another planet's vantage point, the public eye was shut. What ESA did observe remained behind mission walls awaiting analysis. What NASA's orbiters saw, if they were commanded at all, sat in silence. The result was a dead zone, a stretch of days where rumor became stronger than evidence. But rumors do not last forever. They demand confirmation or collapse. And so the natural question arose, would the data, once released, confirm the fears of suppression, or reveal a simple truth that Atlas behaved just like any other comet? As the shutdown days stretched on, speculation turned darker. If silence was policy, then maybe silence was opportunity. If a government wanted to keep something quiet, what better cover than a shutdown when silence was expected anyway? No orders would need to be given, no conspiracy would need to be formed. The system itself would provide the curtain, and behind it, anything could unfold unseen. That was the thought that kept people awake at night. Because when the curtain falls at the exact moment the universe gives you a mystery, suspicion is inevitable. And as October 7th arrived, with Atlas already receding from Mars, the question loomed larger than ever. What, if anything, did those orbiters see that the rest of us were not allowed to witness? The first week of October 2025 is now remembered as more than just the beginning of a government shutdown. It has become a kind of astronomical ghost story, a stretch of days many call the dead zone. Not because spacecraft went dark or instruments failed, but because the flow of information, normally so steady, so reassuring, simply stopped. And in that silence, something uncanny seemed to linger. To understand why this dead zone became so unsettling, we have to strip away the noise and look at how NASA ES operations actually work during a shutdown. The Anti-Deficiency Act is unambiguous. No funds, no work, unless it is to protect life or property. That means astronauts aboard the International Space Station are still monitored, satellites essential for communication or defense still run, and flight controllers at mission control still sit at their consoles. But what doesn't continue is public outreach. The engineers who upload images to NASA servers, the staff who post mission updates, the writers who translate data into press releases, all of them are furloughed. The result is not just silence, but the illusion of inactivity. Imagine logging onto NASA's Mars Reconnaissance Orbiter image archive during that week. Instead of the daily rhythm of fresh frames, you see a static page, unchanging. You refresh, hoping. Still nothing. For those watching from the outside, the absence of new images looked like evidence. For conspiracy-minded observers, it seemed like proof that someone was hiding something. But from inside the system, the truth was more mundane. The people who updated those pages were simply not allowed to work. Yet knowing that doesn't make the silence easier to accept. Because timing matters. If the shutdown had fallen during an ordinary week, with no cosmic visitor in sight, the stillness might have been ignored. But to lose visibility precisely when a hyperbolic traveler brushed past Mars was enough to ignite suspicion everywhere. The optics were terrible. And optics, in a world already hungry for mystery, can be more powerful than facts. It wasn't just silence from NASA, it was contrast. The European Space Agency continued updating the public about their observation campaign. Their scientists gave interviews, explaining how their orbiters would attempt to capture Atlas's light curve and chemical signatures. Amateur astronomers, though hampered by the sun's glare, still posted their limited results on forums. Even some ground-based professional observatories shared faint data. So in one hemisphere of the global conversation, the voices continued. In the other, a dominant voice, the one that usually provided the clearest, sharpest, most frequent updates, vanished. The imbalance was stark, and that starkness made it feel like concealment. Let's look at what counts as a genuine anomaly, as opposed to what was merely normal shutdown behavior. A true anomaly would have been raw images scheduled for release that never appeared. Observation sequences that were planned and then inexplicably missing. Telemetry gaps inconsistent with spacecraft health, or maneuvers that occurred but were never acknowledged. By contrast, a lack of website updates, no press releases, or frozen social media feeds were all exactly what the continuity plan said would happen. The dead zone wasn't evidence of suppression, it was evidence of bureaucracy. But try telling that to people who were watching the skies. It didn't help that rumors spread quickly. On Reddit and YouTube, claims appeared within days that raw images from the Mars Reconnaissance Orbiter had been briefly visible, then pulled, that spectrometer data files looked tampered with, that trajectory logs showed unscheduled burns. None of these claims were verified. Most were probably noise, misunderstandings, or outright fabrications. But in an environment without official updates, rumor thrives like mold in the dark. The absence of authoritative information meant speculation could stretch as far as imagination allowed. And human imagination, when confronted with silence, tends toward the extraordinary. What if Atlas had brightened suddenly, too much for a natural comet? What if its trajectory had shifted in a way equations could not explain? What if its spectrum revealed metals that shouldn't be there? These questions weren't born of evidence. They were born of uncertainty. And yet uncertainty has power. It draws the mind into stories. Still, there were ways to test these stories, even if the data was delayed. One method was timestamps. If later images emerged with October 3rd dates, when Atlas was closest to Mars, that would show they had been captured, just not released at the time. Another was cross-calibration. If ESA's observations and NASA's eventual data told consistent stories about brightness, shape, and chemistry, that would argue against suppression. If they diverged, suspicion would deepen. Amateur astronomers also played a role. They might not have the power to resolve Atlas's nucleus, but they could track its brightness over time. Their independent light curves could serve as a baseline, a check against official claims. The dead zone then was not proof of conspiracy. It was a blank page, But blank pages invite stories, and once those stories take root, they are hard to uproot. Consider the psychology. After Oumuamua, after years of UFO headlines, after decades of cultural fascination with the possibility of alien visitors, here was another interstellar traveler, arriving under the cover of enforced silence. The alignment was too perfect for people not to wonder. NASA itself didn't help. When the agency finally returned to normal operations after funding was restored, there was no immediate flood of Atlas data. Scientists needed time to process and analyze, to calibrate instruments, to write papers. That is how science normally works. But to the public already primed to believe something was hidden, the continued delay felt like confirmation. Silence had created a lens, and through that lens, everything looked suspicious. So what in those 7 days actually happened? Almost certainly, orbiters pointed, instruments ran, and data was stored. ESA later confirmed they had gathered useful measurements, though analysis would take months. NASA, bound by silence, has yet to release its full record. But the comet itself did not wait for politics. It continued its path, gliding past Mars and heading toward perihelion at the end of October. It behaved as comets do, shedding gas and dust, glowing in reflected sunlight, following the laws of orbital mechanics. And yet, the dead zone left a scar, because even if the comet was ordinary, the silence around it made it feel extraordinary. The lack of answers created an information vacuum, and into that vacuum rushed our most human instinct: to search for patterns in the dark. What the dead zone proves is not that secrets were kept, but that secrecy is not required to generate mystery. All you need is absence. All you need is a week of silence in the middle of something rare, and that silence will echo longer than any official explanation. But speculation does not stop at silence. It pushes further, asking, what if the comet itself was not behaving normally? What if the trajectory, the very path it carved through the void, whispered something we were not ready to hear? That is where we must go next, into the mathematics of orbits, the Doppler shifts of light, and the subtle hints of forces that might have nudged Atlas in ways gravity alone could not explain. Silence breeds suspicion, but mathematics leaves less room for interpretation. When words fail, when rumors swirl, numbers remain. And so, while the shutdown shrouded Mars in bureaucratic quiet, astronomers turned to the only thing they could rely on: the trajectory of 3I Atlas. If the comet was strange, the strangeness would show up in its orbit, because orbits do not lie. By definition, Atlas was already unusual. Its eccentricity, how far its path deviates from a closed ellipse, was greater than 1. That meant it was not bound to the Sun. It was not a long-period comet returning from the Oort cloud, nor a stray asteroid nudged inward by Jupiter. It was a true interstellar traveler on a hyperbolic trajectory, entering from the void and destined to leave it again. That alone was rare enough, but the details mattered. If the object was accelerating in ways gravity could not explain, if it shifted off its predicted course, then something more was at play. Astronomers calculate orbits by comparing observations against models. Every telescope, every instrument that tracked Atlas in July, August, and September contributed to the solution. Observers recorded its position relative to background stars, points of light mapped with precision down to fractions of an arc-second. These measurements, when compiled, painted a path across the sky. That path was then fit to equations describing how the Sun's gravity should bend an interstellar object's course. If the observations lined up, the orbit was stable. If they didn't, residuals appeared, tiny discrepancies that hinted at other forces. Comets, of course, are notorious for such forces. As sunlight warms their nuclei, volatile ices sublimate into gas. Jets erupt, pushing dust into space. Every particle carries momentum, and the nucleus recoils with a faint but measurable thrust. Over weeks and months, those thrusts can shift an orbit by thousands of kilometers. Astronomers include parameters for this non-gravitational acceleration in their models, refining them as new data comes in. A wiggle in the trajectory, therefore, isn't necessarily exotic. It could simply be a jet of water vapor firing off into space. But when the shutdown began, the datasets froze, updates from NASA pipelines stalled, and into that gap, speculation crept. What if the shifts were not consistent with natural jets? What if the trajectory revealed something deliberate? Was Atlas steering itself? The suspicion had precedent. In 2018, after studying Oumuamua's odd acceleration, some astronomers argued it was consistent, not with outgassing, but with solar radiation pressure, a gentle push from sunlight itself, amplified by a thin, flat shape, like a light sail. Harvard's Avi Loeb took this further, suggesting it could have been engineered. His theory was controversial, criticized, even ridiculed, but it left a mark. So when Atlas appeared, many wondered, would its path tell a similar story? The numbers through September did not. They showed a hyperbolic orbit consistent with outgassing, not something exotic. Atlas's perihelion, the point of closest approach to the Sun, was calculated for October 29th at about 136 astronomical units. That placed it outside Earth's orbit, a safe pass but close enough for continued observation. The October 3rd Mars encounter was an intermediate step, a chance to watch how the comet behaved as it warmed. At that distance, 30 million kilometers from Mars, even the smallest accelerations might be detectable by orbiters. A deviation in brightness, a change in trajectory, a flicker of rotation, any of these could signal something worth deeper attention. But what did we see? Or rather, what didn't we see? Because during those crucial days, data from Mars was invisible to the public. The Minor Planet Center continued publishing ground-based solutions, but with limited input. The gaps were obvious. To some, they looked deliberate. Let's break down what would count as a real anomaly. First, Doppler shifts. Light carries information about velocity. If Atlas emitted a spectral line, say from water, carbon monoxide, or nickel, the exact frequency of that line could shift if the comet was moving toward or away from us. A sudden or unexplained change in those shifts could indicate acceleration inconsistent with gravity. Second, astrometry. If Atlas's position in the sky diverged from predictions, it would show up in orbital residuals. Even fractions of an arcsecond could reveal unexpected forces. Third, brightness changes. A comet that brightens too fast or dims in ways inconsistent with solar heating suggests structural or compositional surprises. None of these anomalies were confirmed in the data released before the shutdown. But absence of evidence is not evidence of absence. The silence left open the possibility that something was happening unseen. By early October, online speculation was feverish. Some claimed classified sensors, military telescopes, space-based surveillance assets had detected anomalies. Stories circulated of Doppler readings that didn't match the models, or of sudden velocity changes hidden in defense logs. None were verified, and most were likely imagination running ahead of reality. But the idea lingered. What if the anomaly was real and the shutdown was simply convenient cover? Science, however, is slow and relentless. Orbital fits would continue as more data emerged in November and December, when Atlas reappeared from solar conjunction. If the trajectory had shifted unnaturally in October, it would become apparent later. The mathematics would expose it. There is no hiding a path written in the stars. Still, the whispers did not die, because there was another layer of mystery, the comet's composition. And if trajectories left room for doubt, the chemistry of Atlas left room for wonder. The Hubble images in July had provided an estimate of size, but not precision. The nucleus might have been a few hundred meters across or several kilometers. The difference was enormous. A larger, fluffier body of ice and dust would behave like a normal comet, but a smaller, denser body, especially one unusually rich in metals, would challenge assumptions. Mass matters, and without knowing the nucleus's density, astronomers could not decide whether Atlas was ordinary or exceptional. Hints of metal emission lines, particularly nickel, began circulating in the community. Nickel had been seen in other comets, but its presence in Atlas was reported as unusually strong. If true, it might suggest a body richer in heavy elements than expected, a fragment of a shattered planetary core, perhaps, or something stranger. And so suspicion took another turn. If Atlas was massive and metal-rich, perhaps even denser than ordinary comets, what did that mean? Was it a natural fragment from another star system's catastrophe? Or was it something else, an object with properties that invited technological speculation? Numbers alone could not settle the question. For that, spectra were needed. Data locked in orbiters, waiting behind the wall of silence. So the story pivoted. From orbits to chemistry. From paths through space to the matter of which Atlas was made. And with that pivot came new anxieties. Because if Atlas truly was unusual in mass or composition, the strategic implications were vast. Governments would want to know. Agencies might not be eager to share, and silence, already frustrating, would become suffocating. Which brings us to the next chapter of the mystery, the question of metal, mass, and meaning. If Atlas carried within it the fingerprints of a planetary core, or worse, the echoes of something engineered, then perhaps the silence was not only convenient but deliberate. Every comet carries a story etched in ice and dust, a history of its birth environment and its long journey through space. For ordinary comets, icy wanderers of our own solar system, those stories are familiar. Water, carbon monoxide, dust grains of silicates and carbon compounds. But 3I Atlas, our visitor from the stars, has never been ordinary. From the moment its light was first analyzed, whispers of something heavier clung to it, not just the familiar fingerprints of volatile gases, but the spectral scars of metal. Nickel. Here is the problem: size and mass. Hubble had placed Atlas's nucleus somewhere between 1/3 of a kilometer and more than 5 kilometers wide. That range was enormous. A small, icy body would behave predictably, but a small nucleus paired with unusually strong spectral lines implied density. Density meant metal, and density far higher than typical comets pushed Atlas into a new category altogether. Think about what that means. In our own solar system, dense metallic bodies exist, but they are rare. Asteroids like Psyche, believed to be the exposed core of a long-destroyed protoplanet, are largely metal, forged when molten rock differentiated into layers and heavy elements sank to the center. To get fragments of pure metal, something violent must happen. A collision, a catastrophic breakup, a planetary funeral. If Atlas was indeed metal-rich, then it was a messenger carrying proof of ancient violence in another solar system. Perhaps the death of a world around a distant star. perhaps the remains of an asteroid belt blasted apart by time. But there is a darker implication, one that echoes from the debates about Oumuamua. If density was extreme, if metal dominated its spectrum in ways natural models could not explain, then the whispers of engineering would return. Was Atlas a fragment of a planet, or a fragment of something built? Let's pause before diving into speculation. Nickel in comets is not unprecedented. In fact, modern spectrographs have detected nickel, iron, and other metals in several solar system comets. These appear because dust grains containing silicate and metal-bearing minerals are released as the nucleus warms. Sunlight heats them, atoms are liberated, and spectral lines glow. So, in isolation, nickel is not proof of anything unusual. The difference lies in quantity and ratio. If Atlas's nickel lines were stronger than expected, or if their abundance compared to other volatiles seemed off, that would demand explanation. Was the comet forged in an environment richer in heavy elements than our Sun? Was it a fragment of differentiated planetary material? Or was it something stranger still? Theories began to multiply. Some argued that Atlas could be a metallic comet nucleus, dense and heavy, traveling through interstellar space after the destruction of its parent body. Others pointed to the mass estimates circulating in online forums, tens of billions of tons, far above the expected range for a fluffy, icy body of its size. Such numbers were not peer-reviewed, not confirmed, but they spread quickly in the silence of October. And in the absence of official commentary, the imagination of the public did the rest. Imagine for a moment the strategic implications if Atlas were indeed a dense metallic fragment. For decades, futurists have spoken about asteroid mining, about capturing bodies rich in nickel, cobalt, platinum and iron, using them as resources for industry and space. Entire economic models for future civilizations depend on exploiting such bodies. Now imagine a metallic fragment from another star system passing through ours, untouchable because of its hyperbolic trajectory, but observable, a cosmic sample of another system's deep geology drifting past us. Who wouldn't want to measure it, analyze it, catalog it? Who wouldn't want to know how such fragments are distributed in the galaxy? Because if they are common, then interstellar space is not empty. It is littered with relics of broken worlds. That possibility was thrilling, but it was also unsettling. Because if Atlas was indeed metal-rich, another question surfaced. Could anyone decide to keep that discovery quiet? This is where suspicion deepened. If the data revealed nothing unusual, then silence was just bureaucratic delay. But if spectra hinted at densities and compositions out of step with expectations, then governments might hesitate. The public might imagine an alien probe. Industries might dream of interstellar resources. Either way, speculation would spiral. And perhaps, some argued, it was better to let the silence stretch. Of course, no peer-reviewed papers, as of early October, confirmed a metallic nucleus. Most mainstream astronomers maintained a cautious view. Atlas behaved like a comet. Its spectra showed expected gases, and its mass could not be tightly constrained yet. But speculation doesn't need consensus. It only needs uncertainty. And Atlas provided uncertainty in abundance. Here's the deeper, more philosophical point. Metallicity implies history. A chunk of ice tells you about the outer edges of a planetary system, cold and preserved. A chunk of rock suggests a place closer to its star, heated but never melted. But a metallic fragment suggests something entirely different, that melting and differentiation occurred, that a planet or large asteroid once existed, that it broke apart and that pieces were flung into interstellar space. If Atlas carried metals in unusual abundance, then we were not just looking at a visitor, we were looking at a grave marker, the ruins of another world, drifting silently past ours. This interpretation, as grim as it sounds, fascinated the public. Documentaries speculated, blogs filled with diagrams of shattered exoplanets. Forums debated whether Atlas could be the first tangible evidence of catastrophic planetary death outside our system. The narrative was too powerful to resist. The stars were not just nurseries of new worlds, but graveyards of the old. And through those graveyards, fragments wander, waiting to brush past us. But the other narrative, more controversial, clung stubbornly. If a fragment could carry metals, why couldn't it carry something else? Why couldn't it be engineered? If Oumuamua had sparked such debates, why not Atlas too? Especially under the cover of a silence that seemed so carefully timed. The leap from natural to artificial is seductive, perhaps too seductive. But silence amplifies seduction. When official voices are absent, possibilities multiply unchecked. And so the idea grew that Atlas might not be entirely natural, that its density, its metals, its timing, coinciding with the most inconvenient government shutdown in decades, were all signs. Signs of what? Of visitors, of probes, of a galaxy less empty than we assume. To scientists grounded in data, these claims were frustrating. To the public, they were intoxicating. And in October 2025, with no NASA voices to balance the noise, intoxication spread faster than caution. But whether fragment of a broken core or imagined artifact, the question of metal would not go away. Because if metal was truly abundant, it was not merely an academic curiosity. It had implications for planetary science, for galactic archaeology, for industry, and for philosophy. It meant we were looking not at emptiness, but at evidence. Evidence that the galaxy is alive with the debris of creation and destruction. The problem was simple. No one could yet say for sure. Was Atlas a snowball of ices, a rocky shard, a metallic fragment, or something stranger still? As the comet drew closer to the sun, its activity would increase. More gas, more dust, more opportunities for spectra to tell the truth. But for those who waited through the dead zone of October, patience was unbearable. Silence had made them restless, and restlessness led to theories that spiraled further and further from consensus. And so we arrive at the next layer of mystery. Not what Atlas was made of, but how knowledge about it could be controlled. Because even if the data showed nothing exotic, the fact remained. NASA had gone silent. ESA spoke, but cautiously. And in the background loomed other institutions with eyes on the sky, institutions that did not share their findings publicly. The question was no longer only about Atlas itself. It was about us, about the machinery of secrecy, the politics of space, and the ways in which information can be muffled not by conspiracy, but by bureaucracy. Which means our next step is not just about comets, but about agencies, about how silence is manufactured, justified, and sustained, and about why, in some cases, silence is more effective than denial. Silence, when it comes from an institution as vast and visible as NASA, is rarely accidental. It is structural. It is built into the gears of government. And when silence coincides with mystery, people inevitably ask, was this planned? To understand why suspicion clung so tightly to 3i Atlas, we must examine the nature of agencies themselves. Space agencies are not simply collections of scientists. They are political entities, funded by governments, entangled with defense, shaped by legislation, and watched closely by the public. They exist in a constant tension between transparency and secrecy. They are expected to inspire and inform, yet they are also tools of national interest. And in October 2025, that tension was stretched to its breaking point. NASA has always walked this line. Since its founding in 1958, it has presented itself as a civilian agency dedicated to peaceful exploration. Its press offices have delivered photographs of lunar footprints, images of swirling Martian dust devils, the delicate hues of Saturn's rings, and the haunting vistas of the James Webb Space Telescope. NASA's public face is storytelling, and that face has built decades of trust. Yet behind the public imagery lies another reality. NASA is entwined with defense infrastructure. Its rockets were born of ballistic missiles. Its satellites share space with classified platforms. Its tracking stations overlap with those used by the Department of Defense. The line between exploration and security has never been absolute. So when the shutdown silenced NASA, what was really silenced was its public voice. The spacecraft still operated. The data still flowed into antennas on Earth. But much of that data was routed through systems shared with defense agencies. And defense does not go dark during a shutdown. Classified operations continue. Military telescopes keep watch. Strategic sensors never blink, which means that even as NASA went silent, other institutions kept seeing. They were simply under no obligation to share. This dual structure, public silence, private continuity, is fertile ground for suspicion. It creates the impression that something is being hidden, and when that something is an interstellar comet, suspicion becomes irresistible. What if Atlas had shown anomalies? What if classified sensors detected them? Would that information ever be released, or would it vanish into the labyrinth of national security? Consider the nature of classified observation programs. The United States operates a network of space-based telescopes for tracking satellites, monitoring missile launches, and scanning near-Earth space. These are not scientific tools in the civilian sense, but they are exquisitely capable of detecting faint objects. Some can resolve details smaller than a meter on satellites thousands of kilometers away. If Atlas passed within 30 million kilometers of Mars, those sensors could, in principle, detect brightness variations, track its motion and measure its spectrum. But their results would not be released to journals or news outlets. They would be filed into reports marked with stamps, top secret, for official use only. Now think about what happens if anomalies appear in that context. Suppose Atlas's trajectory shifted in ways inconsistent with cometary outgassing. Suppose its spectrum revealed a signature too metallic, too artificial. Would a defense agency announce that to the world? Or would it quietly catalog the data, assess the implications, and keep silent until it understood what it was dealing with? From the perspective of national security, the latter makes sense. Better to remain silent than to ignite global speculation about visitors from another star. And yet silence itself becomes the signal. People notice the absence of words. They notice when a story stalls. They notice when an event of such rarity receives less coverage than a routine Mars dust storm. The quiet becomes louder than any press release could have been. ESA, by contrast, remained vocal. But ESA is structured differently. It is an international collaboration of European nations, its funding streams smaller, its public outreach less entangled with defense. It is not without secrecy, but its culture leans toward openness. That openness created the sharp contrast in October 2025. Europe spoke, America did not. And the gap between those voices became the canvas on which speculation was painted. Let us not forget that suspicion thrives in the wake of precedent. People remembered 2017, when Oumuamua slipped past and debates about its acceleration lingered unresolved. They remembered how quickly theories of alien probes entered the mainstream and how quickly officials dismissed them. They remembered decades of whispers about government knowledge of unidentified aerial phenomena and the congressional hearings that had followed. By 2025, the public had already been primed to believe in secrets. The silence around Atlas was fuel poured onto an already smoldering fire. But there is another layer here, one less about aliens and more about politics. A government shutdown is not just a budgetary event. It is a demonstration of dysfunction. Agencies are paralyzed not because their missions have failed, but because elected officials cannot agree. The image of a government unable to fund its most iconic agency while an interstellar visitor passed nearby was embarrassing. Silence may have been convenient, not only as policy, but as shield. Better no headlines than headlines that screamed, "Shutdown costs humanity its best chance to study alien comet." So the silence had many faces: bureaucratic policy, national security convenience, political avoidance. Each one added weight to the impression that something important was being withheld. For the scientists, it was maddening. Many were furloughed, unable to even check their data streams. They sat at home, watching the same forums and rumors as the public, knowing their spacecraft were alive, but unable to speak for them. Their silence was enforced, not chosen, and yet they became unwilling participants in a drama of secrecy. Meanwhile, Atlas itself continued its path, oblivious to politics. As it passed Mars and arced toward perihelion, its activity increased. Jets fired, dust spread, its coma grew brighter. Every day of silence was another day of data accumulating unseen, and the longer the silence lasted, the greater the gap between what was known privately and what was known publicly. In that gap, speculation about probes began to surface again. If Atlas was rich in metal, was it a fragment, or was it something built? If its trajectory showed anomalies, were they natural, or were they controlled? And if governments had even a hint that something artificial was drifting past, would they ever tell us? Or would they simply watch, record, and remain silent forever? The irony is sharp. If Atlas was ordinary, silence turned it extraordinary. If Atlas was extraordinary, silence only confirmed it. Either way, silence became the amplifier. And so we reach a turning point in the story. Because beyond agencies and politics, there lies another layer entirely: the cultural imagination of humanity itself. When silence reigns, myths are born. And in the autumn of 2025, as an interstellar traveler slipped past our neighboring planet, we began to write myths into the void. The next chapter is not about data or policy. It is about us. About why we need to believe in hidden truths, why silence is so unbearable, and why an object from another star system could ignite our deepest hopes and fears. Human beings do not endure silence easily. Where information ends, imagination begins. And when the subject is as rare and profound as an interstellar visitor, imagination has no limit. The dead zone of early October 2025 didn't just create speculation, it created myth. It became a moment when the public narrative broke free from the anchor of data and drifted into the currents of culture, storytelling, and fear. Think about the context. For decades, we've been trained to expect constant updates from the cosmos. Space exploration is live-streamed. A Mars rover sends back selfies within hours. Telescopes beam their discoveries across social media before papers are even written. The rhythm of transparency has become part of our lives. Then suddenly, silence. A blackout, not caused by technical failure, not by loss of signal, but by policy. Into that vacuum, people turned to what humans always turn to: stories. The first wave of stories was technical speculation. Amateur astronomers and self-taught enthusiasts debated orbital models, brightness fluctuations, and chemical lines. They built theories of metallic cores, fragments of shattered worlds, and non-gravitational accelerations. But the second wave moved beyond science. It wove Atlas into a tapestry of suspicion, weaving connections to old myths of cover-ups, UFO sightings, and government secrecy. It merged the comet with narratives already alive in the culture, and in doing so, it transformed a celestial traveler into a symbol. You could see it in the language of forums and blogs. Atlas wasn't just a comet, it was the messenger. It wasn't just interstellar, it was alien. Some posts framed it as a harbinger, a cosmic omen arriving at the precise moment of political dysfunction on Earth. Others claimed it was surveillance, a probe gliding past us while governments scrambled to keep the truth hidden. The scientific language of density and spectra blurred into the mythic language of intention and purpose. That is the danger of silence. When institutions do not tell the story, people tell it themselves. And when people tell it themselves, they do not limit themselves to what is likely. They leap toward what is compelling. Likelihood takes second place to narrative power. And Atlas, drifting silently past Mars, was rich soil for such narratives. Consider how the timing amplified this effect. October 2025 was not just another month in astronomy. It came after years of heightened public debate about unidentified aerial phenomena. Congressional hearings had pulled the UFO question out of the fringes and into mainstream politics. Reports of non-human craft had made headlines, whether credible or not. A cultural lens had already been polished, ready to interpret cosmic silence as cosmic secrecy. Atlas did not enter a vacuum. It entered a world already primed for suspicion. In that world, every absence was filled with intent. Why did NASA go silent? Because, said the narratives, they knew more than they wanted to admit. Why did ESA speak but cautiously? Because they were under pressure not to reveal too much. Why did amateur observations remain inconclusive? Because the object was not natural, and governments were controlling the flow of real images. These were not conclusions, they were stories. But stories spread faster than conclusions. And once a story spreads, it becomes sticky. The idea that Atlas was more than a comet, perhaps a probe, perhaps a fragment of technology, was irresistible. It echoed back to Oumuamua, whose peculiar acceleration still haunted the public imagination. It tapped into science fiction, into ancient fears of watchful skies, into the archetypal human suspicion that we are not alone. Silence became confirmation bias. Whatever you already believed, the silence of October seemed to support it. For some, Atlas was a threat. Forums whispered about harbingers of catastrophe, about ancient prophecies of cosmic messengers arriving before upheaval. They merged the comet's name with apocalyptic imagery. They spoke of worlds destroyed and civilizations judged. For others, Atlas was a sign of hope, a visitor carrying proof that life, technology, or intelligence existed beyond our sun. The same silence that frightened some became inspiration for others. What unites both interpretations is the human need to fill the void. Our species cannot stare at uncertainty for long without constructing meaning. And in the autumn of 2025, meaning was constructed in abundance. The interstellar traveler became less a comet and more a mirror, reflecting our anxieties and our aspirations back at us. But here is where we must tread carefully. Myth and speculation are not evidence. They can inspire, but they can also distort. If Atlas truly was unusual, science would eventually reveal it. Orbits would be refined. Spectra would be published. Papers would appear. But by the time those results trickled into journals, the cultural story had already hardened. The myth of silence had already taken root, and myths, once planted, are hard to uproot. This is the paradox of modern discovery. Science works on timescales of caution and verification. Culture works on timescales of immediacy and imagination. The gap between those timescales is filled with uncertainty, and uncertainty is fertile ground for stories. Atlas happened to pass through that gap at the exact moment when silence was at its thickest. And so part 7 of our story is not about Atlas itself, but about us. About how we construct myths from absence, how we assign intention to silence, how we weave a cosmic traveler into our own narratives of secrecy, threat, and hope. The comet became a stage, and onto that stage we projected everything we fear and everything we long for. Yet behind the myths, a more practical question remained. Beyond culture, beyond speculation, beyond rumors of probes or fragments, there was the harder truth. The data did exist. Instruments had recorded it. Files had been stored. Somewhere, in spacecraft memory banks and ground-based servers, photons from 3I Atlas were preserved. They were waiting for the machinery of bureaucracy to restart, waiting for scientists to return from furlough, waiting for analysis to pull meaning from the noise. And so the question sharpened. What would happen when that data finally emerged? Would it confirm the myths or collapse them? Would it show a comet as ordinary as any other, or reveal signatures that justified the silence? The answer would not come quickly. It would take months. But while the scientists worked, the myths spread, becoming stronger than evidence. This is the rhythm of our species. We are not just seekers of truth, we are makers of stories. And in October 2025, as Atlas slipped past Mars and vanished into sunlight, we proved once again that the cosmos does not just reveal itself to us, it reveals us to ourselves. And as the silence stretched, another thought crept into the conversation, a thought darker than myth and stranger than rumor. If silence was so effective at amplifying mystery, what if it was not an accident? What if silence itself was the strategy? What if silence was not an accident? What if it was a strategy? That question began to creep into discussions in the weeks after 3I Atlas swept past Mars. At first, it was speculation born of frustration, but soon it became a serious thread in the tapestry of theories surrounding the interstellar visitor. Because silence, when wielded carefully, is not absence. It is power. Governments have always known this. In intelligence and defense circles, silence is a tool. Sometimes you release information to shape perception. Sometimes you withhold it to starve narratives of oxygen. But sometimes silence itself becomes the narrative. A blank space can be louder than words. It can frame the imagination, channel public thought, and test reactions without revealing anything. In October 2025, that possibility seemed all too real. Imagine the scenario from the perspective of an agency under pressure. An interstellar comet has been discovered. It shows unusual properties, perhaps in brightness, perhaps in spectra, perhaps only in the public's interpretation. Observers around the world want answers immediately, but the agency knows two things. First, that science cannot move at the speed of rumor, and second, that any premature statement will fuel speculation more than silence ever could. So they choose silence. They lean on the convenient shield of the shutdown. They let absence become the answer. This is not conspiracy in the classic sense. It is bureaucracy weaponized. No need for secret meetings in smoke-filled rooms. No need for clandestine cover-ups. Just let the system do what it already does. Pause public communication, and the result is the same as deliberate secrecy. To the outside world, the silence looks suspicious. To the inside world, it looks safe. But the danger of using silence as strategy is that it cannot be controlled. People interpret it in unpredictable ways. In the case of Atlas, some saw silence as confirmation of anomaly. Others saw it as evidence of incompetence. Still others believed it was both, that something unusual was happening and that the government had bungled its chance to explain it. Silence became a mirror for every worldview. Here's the irony. In wielding silence as a shield, agencies may have created the very storm they wished to avoid. By saying nothing, they created a vacuum. And in that vacuum, myth bloomed, rumors hardened, distrust deepened. Silence, instead of suppressing speculation, amplified it. The comet became not just an astronomical object, but a cultural event, a cipher onto which entire societies projected suspicion. Some argued this was intentional, that governments wanted to observe not just the comet but us, that by allowing silence to stretch, they could measure how populations responded, how conspiracy movements evolved, how rumors metastasized. In other words, Atlas was not just an interstellar test, it was a social test, a live experiment in information control. This theory gained traction online not because it was likely, but because it was compelling. People pointed to the coincidence, a shutdown arriving exactly as a once-in-a-lifetime astronomical event unfolded. They pointed to the contrast between ESA's openness and NASA's silence. They pointed to the timing of delayed updates, the absence of images, the rumors of vanished files. And they wove these threads into a larger tapestry, silence as experiment, silence as strategy. But let's ask the harder question. What would such a strategy achieve? If silence was deliberate, what was the goal? One possibility: containment. By withholding data, agencies prevent premature or misleading interpretations. They give scientists time to analyze before public frenzy sets the tone. Another possibility: protection. If something truly extraordinary were detected, say metallic density beyond expectation or anomalous trajectory, silence gives governments time to decide how to frame the discovery. And a third possibility: distraction. A shutdown already creates political chaos. Burying an extraordinary event beneath that chaos ensures fewer eyes notice. Silence, in this case, is camouflage. The paradox is that all three possibilities, though logical, lead to the same outcome: distrust. Because once silence hardens, the public assumes the worst. Transparency delayed feels like transparency denied. And when people finally do see the data, they view it through the lens of suspicion. Even if Atlas turns out to be ordinary, the myth of silence has already reshaped the narrative. This is not a new phenomenon. History is littered with examples. In 1986, when the Chernobyl disaster unfolded, silence from officials fueled panic across Europe. In 2003, delays in releasing satellite images of the Columbia shuttle breakup sparked conspiracy theories. In 2017, the odd acceleration of Oumuamua lingered in silence, long enough for alien probe theories to go mainstream. Time and again, when institutions fall silent, culture fills the gap with stories far more powerful than reality. Atlas in 2025 was simply the latest chapter. Yet Atlas was different in one crucial way. It was interstellar, not a local rock, not a comet from the Oort cloud, a traveler from another system entirely. That distinction magnified the stakes. Because if silence surrounds something from beyond our sun, it carries implications far beyond planetary science. It whispers of civilizations, it hints at surveillance, it fuels the idea that governments are hiding proof that we are not alone. Silence, in this case, does not just obscure, it amplifies cosmic paranoia. And so October 2025 became a cultural experiment, whether intentional or not. The comet's scientific details almost didn't matter. Its orbit, its mass, its spectra, all of these were drowned out by the louder narrative, the narrative of silence. People will remember less what Atlas was, and more how little they were told about it. But there is a deeper, subtler danger to wielding silence as strategy. If you use silence too often, it becomes expected. It creates a baseline of distrust. The next time a shutdown or blackout occurs, people will not assume bureaucratic delay. They will assume secrecy. Silence stops being neutral and becomes accusatory. Agencies, in trying to shield themselves, end up weakening themselves. Still, the notion of silence as strategy refuses to die, because it fits so well with the facts. NASA did not speak. ESA did, but cautiously. Classified systems certainly observed, but said nothing. The public was left to invent the story. And governments, by refusing to engage, effectively conducted a live experiment in myth-making. Which brings us to the heart of the matter. What if silence itself was the point? What if the true anomaly of Atlas was not in its orbit or its metals, but in us? In how we responded, how we speculated, how we wove myths from absence. What if the interstellar traveler was less a messenger of another star system and more a mirror reflecting the psychology of Earth in 2025? That idea is haunting, because it means the story is not only about Atlas at all. It is about our civilization's relationship to knowledge, secrecy, and trust. A relationship frayed by decades of withheld truths, from classified programs to delayed scientific results. A relationship that has made us more eager to believe in silence than in words. And so, as Atlas slipped past perihelion at the end of October, the comet itself became secondary. What mattered more was the silence around it, and what that silence revealed about us. But myths are not the end of the story. Beyond silence, beyond suspicion, there are the hard questions science must still answer. What was Atlas's true mass, its true density, its chemical fingerprints, its structure, its rotation, its fate as it receded back into the dark? The months after perihelion would be crucial, and in those months, data would trickle out. Too late to kill the myths, but enough to begin separating fact from fiction. Which brings us to the next chapter of this mystery, the release. When the silence lifts, when the first post-shutdown analyses emerge, what do they show? Do they confirm ordinary cometary behavior? Or do they hint, however faintly, at something extraordinary that silence could not contain? When silence finally begins to lift, it never comes all at once. It comes in fragments, an image here, a spectrum there, a technical abstract buried in a conference presentation. For those who had lived through the dead zone of October 2025, every fragment felt electric. Each piece of data released after the shutdown was scrutinized, not only for what it showed, but for what it failed to show. Because when silence lasts too long, the first words that break it carry the weight of suspicion. The first trickles of data emerged not from NASA's public channels, but from Europe. ESA's ExoMars Trace Gas Orbiter and Mars Express team released preliminary statements confirming that they had indeed observed Atlas during its closest approach to Mars. Their phrasing was cautious, technical. They spoke of preliminary light curves, of spectral measurements requiring calibration, of ongoing analysis. Nothing sensational, no grand claims of anomalies. To most scientists, this was expected. To the public, conditioned by weeks of rumor, it felt like evasion. Then came the first images, faint streaks captured against a backdrop of stars, showing Atlas as a fuzzy point of light. To the trained eye, they were valuable. They confirmed brightness, coma structure, and orientation. To the untrained eye, they were underwhelming. After weeks of silence, many had expected clarity, revelation, even drama. Instead, they got smudges of light. The gulf between expectation and reality widened. But within those smudges were clues. Careful measurements revealed that Atlas's coma had expanded more rapidly than predicted. Its brightness curve suggested higher activity than most models had anticipated. Outgassing was strong, producing a tail laced with dust and ions. That was not anomalous in itself. Comets often flare unpredictably, but it fueled ongoing debates about density. Was this the behavior of a fragile, icy body shedding material too quickly, or the behavior of a dense metallic core venting through cracks in its surface? Spectral data too began to arrive. Here the story grew stranger. Nickel lines were indeed present, stronger than average, but still within the realm of possibility. Iron was also detectable, along with the expected volatiles: carbon monoxide, carbon dioxide, water. The ratios were odd though. Some scientists noted that the proportion of heavy metals seemed high compared to typical solar system comets. Was that a sign of exotic origin? Perhaps. But exotic in astronomy does not always mean artificial. It can mean simply that the comet formed in an environment with a different chemical fingerprint than our own. Another star's nursery, another star's debris field. Still, the public seized on the metals. Articles with breathless headlines asked if Atlas was the fragment of a destroyed exoplanet. Others revived the old whispers. Could it be engineered? The myths birthed in silence did not die in the light of data. They adapted, feeding on it, bending it to their narratives. Where scientists saw ratios to be studied, the public saw signals to be decoded. NASA's eventual return to communication did little to help. When the shutdown ended, the agency faced a backlog of work. Press offices had to restart, scientists had to catch up on furloughed analysis, and priorities had to be set. Atlas was important, but it competed with dozens of other missions. The first formal NASA statement about Atlas after the silence was clinical, even bland. It confirmed that Mars Reconnaissance Orbiter and MAVEN had conducted limited observations. It stated that preliminary results were consistent with cometary activity. No anomalies, no extraordinary claims. To those already suspicious, it sounded like a brush-off. And yet, hidden within the technical documents, the data told a subtler story. HiRISE, the powerful camera aboard MRO, had recorded brightness variations that hinted at rotation. The period seemed unusual, slower than many expected, possibly tumbling. MAVEN's instruments detected interactions between the comet's tail and the solar wind, including faint magnetic fluctuations. None of these were unprecedented. All were consistent with natural cometary behavior. But each detail was seized on by those who wanted more. Was the tumbling a sign of irregular shape? Was the magnetic disturbance evidence of something metallic at its core? The ordinary became extraordinary simply by passing through the lens of suspicion. This is the tragedy of delayed transparency. By the time the truth emerges, the myth has already taken root. Data no longer functions as anchor. It becomes fodder. In the case of Atlas, every chart, every spectrum, every brightness curve was filtered through narratives of secrecy. To believers, the numbers confirmed that governments were hiding the comet's true nature. To skeptics, The same numbers confirmed that nothing unusual had ever happened. The silence ensured that no explanation could satisfy both. But here lies a deeper truth. Atlas did not need to be artificial to be extraordinary. Even as an ordinary comet, it was remarkable. It was a fragment of another star system, flung across interstellar space for millions of years, brushing past Mars at a moment when humans could watch. Its metals, its gases, its rotation, all of these were not just data points, but whispers from another system's history. The fact that we could record them at all was astonishing, yet the silence had warped perception so much that ordinary wonder was no longer enough. People demanded anomaly, they demanded strangeness, and when strangeness was not found, they manufactured it. Scientists pressed on regardless. By November and December, conference papers began to appear, filled with cautious conclusions. Atlas behaved broadly like a comet, though its composition hinted at unusual richness in heavy elements. Its orbit remained hyperbolic, no evidence of control or propulsion. Its nucleus likely measured 1 to 2 kilometers in diameter. Its rotation was irregular but not implausible. In other words, natural, if peculiar. Yet the cultural narrative told a different story. The narrative said, "They are not telling us everything." And so, paradoxically, the silence of October continued to echo months later, louder than the data itself. The dead zone had become the defining feature of the Atlas story. Even as scientists built models and wrote papers, the public's memory remained fixed on that week when NASA said nothing. This reveals something profound about our species. We crave meaning more than truth. When truth is delayed, meaning rushes in to fill the void. Atlas, the third interstellar visitor, was a comet in the language of science, but in the language of culture, it became something more. A symbol of secrecy, a mirror of distrust, a reminder that silence itself can be louder than revelation. Yet even in this noise, one question continued to haunt both scientists and dreamers alike. If Atlas was natural, why did it appear so strange? And if it was strange, why did the silence fall so perfectly at the moment it passed? The truth may never fully be disentangled, but the search for truth does not stop. In the months after perihelion, as Atlas drifted outward, astronomers prepared for the long watch. They would continue to track its fading light, measure its trajectory, and squeeze every last clue from the data. Because even if silence had warped the narrative, the comet itself still carried answers. Answers written not in policy, but in physics. And as we move forward in this story, we must ask, did the release of data truly end the mystery, or did it simply deepen it by showing us just enough to wonder what was missing? When science finally speaks, it speaks in papers, conferences, and careful abstracts. Its language is measured, cautious, designed to avoid overstatement. But myths do not obey those rules. They are loud, immediate, and emotional. And when the two collide, as they did in the months after 3I Atlas swept past Mars, the clash is less about evidence and more about trust. By December 2025, the first peer-reviewed analyses of Atlas were filtering through. Astronomers presented results at winter conferences, sharing orbital refinements and compositional studies. The conclusions were cautious, but clear. Atlas was behaving like a comet. Its orbit showed no evidence of propulsion or control. Its brightness fluctuations matched natural outgassing. Its spectra revealed volatiles and metals, yes, but within the expected range for bodies formed under different stellar chemistries. In short, Atlas was extraordinary because it was interstellar, but not because it was engineered. Yet outside those conferences, the cultural narrative had moved too far. To the public that had lived through the silence, The ordinary explanations felt like dismissal. Words like natural variability, uncertain modeling, and in line with expectations sounded evasive. After all, if it was so ordinary, why had the silence been so profound? Why had one of the most visible agencies on Earth gone mute at the exact moment a cosmic visitor appeared? No amount of data could erase that suspicion. This is where Atlas crossed the threshold from science into legend. It was no longer just a comet, it was a symbol of bureaucracy, of secrecy, of the fragility of trust in institutions. Every paper confirming its natural behavior was met with two reactions: relief among scientists and skepticism among those already convinced of concealment. The shutdown had forged two narratives, and no evidence could fully reconcile them. To scientists, Atlas was a treasure. It offered a glimpse into the materials of another star system. Its nickel and iron lines hinted at a parent environment richer in heavy elements than our own. Its coma revealed chemistry shaped by stellar evolution elsewhere in the galaxy. Each photon captured was a fragment of an alien past, delivered to us by chance. Even ordinary data from Atlas was extraordinary because it showed us that the galaxy is not uniform, that worlds are forged under different conditions, and fragments of those worlds drift across the stars until fate brings them here. But to the public, shaped by silence, Atlas was proof of something else. Proof that governments cannot be trusted to tell the full story. Proof that extraordinary events are always concealed. Proof that the truth, whatever it is, must be stranger than the official line. In that sense, Atlas joined a long lineage of mysteries where the absence of immediate transparency mattered more than the eventual evidence. It became the latest Roswell, the latest Oumuamua, the latest entry in humanity's endless suspicion of silence. The irony is sharp. The very thing that made Atlas extraordinary, its interstellar origin, was overshadowed by myths of what it might have been. A comet from another system should have been enough to inspire awe. But the silence had raised expectations so high that only revelation of alien technology would have satisfied them. When the truth arrived, measured, cautious, ordinary by comparison, it was met with disappointment, even derision. Wonder had been replaced by suspicion, yet there is a deeper lesson here, one that transcends the specifics of Atlas. It is the lesson of how we as a civilization process mystery in the age of constant information. Transparency has become so normal that its absence feels like deceit, delay feels like denial, silence feels like strategy, and when silence meets rarity, when it coincides with a once-in-a-lifetime event, the effect is amplified 1,000-fold. Atlas became less a comet and more a cultural stress test, revealing just how brittle the bond of trust between institutions and the public has become. Scientists, for their part, tried to reclaim the narrative. They published not just data, but also outreach articles, emphasizing the wonder of interstellar visitors. They reminded the public that Atlas was only the third object of its kind ever detected, a remarkable confirmation that our solar system is not isolated but constantly brushed by fragments of other stars. They framed Atlas as a window into galactic history, a messenger not of aliens, but of physics and chemistry written on a cosmic scale. But in the digital sphere, those voices struggled to compete. Forums and influencers leaned into the myths. Videos speculated about hidden images, about military sensors capturing what NASA would not release, about metals too pure to be natural. Algorithms rewarded speculation over caution, and so the myth of Atlas grew stronger, even as the scientific picture grew clearer. Yet myths, for all their distortions, serve a purpose. They reveal our anxieties, our hopes, our cultural state of mind. In the story of Atlas, the myth was not just about comets. It was about trust, secrecy, and our hunger for contact. It was about a civilization that feels watched, that suspects its leaders of concealment, that longs for proof of life beyond Earth, but also fears what such proof might mean. Atlas, in that sense, was not just a visitor from another star system. It was a mirror showing us who we are when faced with silence. And so as 2025 drew to a close, two atlases existed side by side. One was the comet of science, a hyperbolic traveler, metal-rich, natural, a fragment of another star's history. The other was the atlas of myth, a probe, a signal, a secret, a silence stretched across the sky. Which one will endure in memory? Perhaps both. Science writes papers, myths write themselves into culture, and culture, in the long run, often wins. But the story is not over, because Atlas, though fading as it receded from the sun, had already set something in motion. It had sparked a renewed hunt for interstellar objects, a race to prepare for the next one. Agencies began to discuss interception missions, probes that could meet the next traveler before it slipped past. The silence of October 2025 had taught a harsh lesson. If we are not ready, we may lose our chance. And next time, silence will not be an excuse. Which leads us to the next phase of this unfolding saga, the future. Because Atlas was not the last, more interstellar wanderers will come, and the question we now face is not just what they will be, but how we will respond. Will we meet them with preparation and openness, or with silence and myth? The silence of October 2025 did more than spark myths. It left a scar. A scar not only on public trust, but on the scientific community itself. Researchers who had spent their careers preparing for rare opportunities suddenly realized how fragile those opportunities were. A single political decision, a shutdown, a frozen budget, had muted humanity's response to a cosmic visitor. For many, it was unacceptable. The lesson was clear. We could not afford to stumble again, because 3i Atlas would not be the last. Astronomers knew this with certainty. The galaxy is vast, filled with fragments cast adrift by gravitational slingshots and stellar catastrophes. Objects like Oumuamua, Borisov, and Atlas are not rare. They are simply rare to detect. With every improvement in survey technology, the likelihood of discovery rises. And now, with new instruments on the horizon, we stand on the cusp of seeing not just one or two interstellar travelers per decade, but many. The challenge is no longer if they will come, it is how we will respond when they do. The search is already underway. Ground-based observatories like the Vera C. Rubin Observatory in Chile, expected to begin full operations soon, are designed to sweep the sky with unprecedented depth and frequency. Its legacy survey of space and time will catalogue billions of objects, spotting faint wanderers that would once have slipped by unnoticed. With such eyes on the sky, the discovery of future interstellar visitors is inevitable. The real question is whether we will be ready to meet them up close. Because telescopes, for all their power, are limited. They can tell us about brightness, trajectory, and chemistry, but they cannot touch, they cannot sample, and interstellar visitors do not wait. They arrive suddenly, on hyperbolic paths, and within months they are gone forever. To truly understand them, to pull their secrets from the dark, we must go to them. We must intercept. The idea of an interstellar interception mission is no longer science fiction. For years, organizations like the Initiative for Interstellar Studies have proposed concepts for spacecraft that could chase down visitors like Atlas. These missions require speed, more speed than humanity has ever achieved with robotic probes. They demand rapid launch capabilities, adaptive targeting, and instruments designed for fast flybys. And most of all, they demand readiness. You cannot wait until the object is discovered to begin designing a mission. By then, it is too late. Atlas, in its fleeting pass, underscored this urgency. We watched it slip past Mars, tantalizingly close, and yet we were helpless. We could not chase it. We could not reach it. All we could do was record faint light and argue over its meaning. For many in the scientific community, that helplessness was intolerable. If the galaxy is delivering messengers to our doorstep, we cannot remain bystanders. Already, new mission concepts are being drafted. Ideas for probes that could be launched on standby, waiting in space until a target appears. Ideas for propulsion systems, solar sails, nuclear thermal engines, even speculative fusion drives that could accelerate fast enough to close the distance. Ideas for swarm probes, releasing dozens of small instruments to capture every angle of a flyby. What Atlas revealed was not just our vulnerability to silence, but our vulnerability to inaction. Without preparation, we will lose the next chance as surely as we lost this one. Yet preparation is not only technical, it is also political. The shutdown showed how fragile the chain of communication can be. Even with spacecraft active, even with instruments recording, the absence of authorized voices turned data into rumor. If we are to intercept future visitors, we must also intercept the failures of bureaucracy. We must build systems that can operate beyond political silence. The cosmos does not pause for budgets. Interstellar travelers do not wait for appropriations. If we are not ready, the next myth will write itself before the next comet even arrives. But there is another urgency, one less spoken of yet just as important. Every interstellar visitor is a piece of another world, a fragment of another solar system's story. Studying them is not just science, it is archaeology on a galactic scale. Each object carries within it the fingerprint of a different star, a different environment, perhaps even a different history of life. To miss them is to miss the chance to hold in our hands evidence of how worlds are born, how they die, and how they scatter their remains into the void. Atlas may have been ordinary. It may have been nothing more than an icy fragment rich in metals, behaving within the bounds of natural physics. But even ordinary interstellar fragments are extraordinary. They are ambassadors from distant suns. They are our only direct samples of other systems until the day we can send probes to those stars. And in them may lie answers to questions as old as humanity itself. Are we alone? Are planets like ours common? Does life arise elsewhere? Each fragment is a clue, and each clue is fleeting. The cultural impact of Atlas's silence, then, may have one positive consequence. It has awakened urgency. Agencies, foundations, even private companies now speak of next time. Next time we will not be caught unprepared. Next time, silence will not be the only response. Next time, we will chase. But what if next time is stranger? What if the next interstellar visitor does not behave like a comet at all? What if its orbit defies expectations, its composition defies chemistry, its appearance defies explanation? What if silence is not enough to contain the myth? That possibility lingers, haunting every plan. Because once a door has been opened, it cannot be closed. We are now aware that the galaxy sends us fragments, and awareness changes everything. Which brings us to the unsettling heart of the matter. Atlas may not have been the probe some imagined, but what if the next one is? What if among the natural fragments one day, something engineered truly does appear? Will we recognize it? Will we admit it? Will we tell the world or fall again into silence? The race then is not only against time and trajectory. It is against ourselves, our politics, our myths, our silence. And the stakes are higher than any single comet, because if we stumble again, the galaxy may never forgive us. The question now is simple yet profound. When the next messenger arrives, will we meet it with readiness, or will we bury it in silence once again? Speculation about 3I Atlas, whether it was a fragment of a shattered world or merely an icy traveler, always circled back to one haunting possibility. What if the next one is different? Because as extraordinary as Atlas was, it still behaved more or less like a comet. It vented, it brightened, it developed tails, it tumbled. Strange, yes. Exotic, perhaps, but not impossible. Its physics obeyed the rules we knew. And yet those rules are not guaranteed forever. The galaxy is vast. Its variety is infinite. Somewhere out there, something may travel differently. Imagine for a moment an interstellar visitor that does not shed gas or dust. No coma, no tail, no cometary flares, just a silent rock gliding through the solar system as though sculpted for stealth. To telescopes, it would appear almost star-like, faint and smooth, without the messy halo that makes comets easy to spot. Detection would be harder, its trajectory harder to refine, its surface harder to study. Such an object could pass close by and slip away almost unnoticed. Unless, of course, it was designed that way. Or imagine the opposite. A visitor that flares too brightly, brighter than physics allows. A body that does not dim with distance as it should, that reflects or emits light in ways that defy chemistry. Spectra that carry no familiar fingerprints of carbon or oxygen or metals, only flat, featureless bands, like polished alloys or manufactured composites. How would we respond to such a puzzle? Would scientists speak openly? Would governments remain silent? Would the public accept cautious phrases like unknown reflectance, or would they leap directly to artificial? The truth is, our preparation is weakest not in technology but in psychology. We are ill-prepared for ambiguity. Atlas proved this. The mere hint of odd nickel lines, the coincidence of silence, the normal irregularities of brightness, all were enough to birth a mythology of probes and secrecy. What then would happen if an object truly did defy expectation? The storm of rumor would be unstoppable. The myths would bloom instantly, and perhaps no amount of evidence could control them. Scientists have long debated what to do if an object like that appears. The protocols for detecting asteroids that threaten Earth are clear: track, calculate, announce. But what are the protocols for detecting something anomalous, something that might not be natural? Who decides what is said and when? Atlas hinted at these questions but did not force them. The next visitor might. And here lies the haunting possibility. What if the galaxy has already sent such a messenger and we missed it? What if among the countless faint streaks of light recorded in old photographic plates or hidden in the margins of survey data, there is already evidence of something strange, something we overlooked because it did not fit our categories? After all, Oumuamua itself was discovered only after it had passed closest to Earth, already retreating. Atlas was found just months before perihelion. How many more slipped by invisible in centuries past? This line of thought is not just paranoia. It is humility. We have only recently built instruments capable of sweeping the skies systematically. For most of human history, the heavens were mapped by the naked eye. Even today, we can miss what does not behave as expected. If the galaxy wished to send us a riddle, it would not need to hide it. Our own limitations would be enough. Yet consider the inverse possibility, that one day we will not miss it. That one day a visitor will appear whose behavior cannot be brushed aside, a trajectory too precise, a signal embedded in its spectrum, a structure that looks carved, not eroded. The moment will come when ambiguity collapses, when caution gives way to certainty. The question is not whether we will find such an object. The question is whether we are ready to face what it means. Atlas's greatest legacy may be in forcing us to confront this psychological unpreparedness. Its silence-trained myth showed how quickly imagination fills voids. Its ordinary extraordinariness revealed how fragile trust has become. It demonstrated that we are not only searching the stars for evidence, we are searching ourselves, testing the limits of belief, of patience, of openness. Atlas did not break those limits, but it pressed against them. The next one might. And if that day comes, if the next visitor refuses to fit into our categories, the reaction will ripple across every domain. Science will scramble to explain. Governments will weigh what to reveal. Cultures will fracture into believers and skeptics. Economies will shift. Markets will panic or surge. Religions may claim prophecy fulfilled. Humanity will not just observe, it will be transformed. We must be honest about this. The discovery of something truly anomalous will not unite us immediately. It will divide us first. Atlas showed this in miniature. A natural comet was enough to create two narratives, scientific and mythic, that could not reconcile. Imagine then the scale of division if the evidence were undeniable, if ambiguity favored the extraordinary. The storm will not be gentle. It will test not only our science, but our civilization. And yet in that test lies opportunity. The next visitor, whether natural or artificial, will force us to grow. It will force us to confront not only what drifts through interstellar space, but what drifts within us, the silence, the myths, the fears, the hopes. Perhaps the true message of Atlas was not about its metals or its orbit, but about readiness. It asked us, without words, when the extraordinary comes, will you be ready to listen, or will you only project? As Atlas faded into the black, scientists prepared. They sharpened their instruments, refined their models, drafted their mission concepts. But somewhere deeper, beyond science, humanity itself began to prepare in another way. Quietly, uneasily, we began to realize that the next time the silence cannot hold. The next time, whatever the truth may be, it will demand an answer. And so the narrative turns from the comet itself to the possibility of the future. The arrival of an object that forces our hand, that strips away silence, that leaves no room for denial. That possibility is not far-fetched. It is not science fiction. It is inevitability. Because the galaxy does not care about our readiness, it does not slow for our politics. It continues endlessly, scattering its fragments across the dark. And one day, one of those fragments will not be ignorable. The only question that remains is this: when that fragment appears, will humanity meet it with unity, or will we fracture again into silence and myth? When we speak of interstellar visitors, we often reduce them to data points, trajectories, spectra, light curves, numbers and charts that fit neatly into scientific journals. But the deeper truth is that such visitors are not only astronomical events, they are cultural events. They are mirrors forcing us to confront questions far larger than physics. And if 3i Atlas taught us anything, it is that the cultural reaction can matter as much as the science itself. Now imagine what happens when ambiguity collapses, when the next visitor arrives and its nature cannot be softened into comet or asteroid. Imagine that it bears the unmistakable marks of design, a geometry too precise, a surface too polished, an orbit too controlled. In that instant, humanity would find itself in a moment it has anticipated for centuries, the realization that intelligence exists elsewhere. Not speculation, not whispers, but evidence. And evidence transforms everything. The first transformation would be psychological. For centuries, humans have lived under two competing assumptions, that we are alone and that we are not. Both assumptions have shaped religions, philosophies, and worldviews. The sudden collapse of ambiguity would tear through those assumptions. For those who believed we were alone, it would be shattering. For those who believed we were not, it would be vindicating. But even vindication carries shock. To know for certain that intelligence exists beyond Earth is not just to expand the universe. It is to shrink ourselves, to place humanity within a broader hierarchy of existence. And that shift would reverberate through every layer of identity. Religions would wrestle with the discovery. Some would interpret it as confirmation, angels by another name, messengers of the divine. Others would see it as a challenge, forcing doctrines to stretch or fracture. For philosophies rooted in human centrality, the blow would be existential. For those built on cosmic humility, it would be liberation. But no tradition would escape untouched. The second transformation would be political. The silence around Atlas already revealed how fragile communication can be. How would nations react to undeniable evidence of intelligence? Would they unite under a shared mission to understand? Or would they retreat into secrecy, guarding knowledge as a strategic asset? History suggests the latter. The instinct to control, to weaponize, to dominate is strong. Yet the enormity of the discovery might push against that instinct, creating pressure for global transparency. For the first time, humanity might be forced to choose between survival of myth and survival of truth. Economics, too, would tremble. A confirmed artifact from another system would carry implications for technology, for industry, for the balance of power. Even if the object were inert, its existence would suggest that advanced civilizations have crossed the gulf between stars. If they could, might we? Suddenly, propulsion concepts dismissed as fantasy, fusion drives, antimatter engines, light sails would acquire urgency. Investment would surge. The very idea of progress would accelerate, driven by fear of being left behind in a galaxy that no longer feels empty. But perhaps the most profound transformation would be cultural. Humanity thrives on narrative, and the arrival of undeniable evidence would become the greatest story ever told. It would reshape art, literature, cinema, music. It would inspire new myths, new religions, new movements. It would fracture some communities and unify others. The we of humanity would be redefined, no longer framed only against nations, tribes, or ideologies, but against the backdrop of the stars themselves. The danger is that we are not ready for such transformations. Atlas showed us this in miniature. Faced with silence, we leapt into myth. Faced with ambiguity, we fractured into camps. If that was our reaction to a comet that likely was natural, what will our reaction be to an object that is undeniably artificial? Will we collapse into chaos or rise into something greater? And here lies a sobering truth. Preparation is not only technical, it is not enough to build faster rockets or sharper telescopes. We must also build resilience in our culture, in our politics, in our psychology. We must learn to hold ambiguity without shattering, to process mystery without drowning in myth. If we cannot, then the arrival of undeniable proof will not enlighten us, it will break us. Yet there is hope. For every voice lost in conspiracy, there are voices of reason. For every myth, there is science. For every silence, there is persistence. The very fact that Atlas was studied, that data emerged despite shutdowns and suspicion, shows that the machinery of knowledge still moves. Perhaps imperfectly, perhaps slowly, but it moves. And that movement will only grow stronger as the possibility of contact grows more real. In this sense, Atlas may be remembered not for what it was, but for what it revealed. It showed us that the galaxy does not just send us fragments, it sends us tests. Tests of our trust, our patience, our imagination. We passed imperfectly, stumbling into suspicion and myth. But perhaps that stumble was necessary. Perhaps it prepared us for the greater tests to come, because they will come. More interstellar visitors will sweep through our skies. Some will be ordinary, others strange, and one day, perhaps soon, one will force the question beyond denial. That day will be the dividing line in history, before proof and after proof. Everything will be different on the far side. The question we must carry then is not just what will we find, but what will it make of us? Will discovery deepen our fractures or heal them? Will it fuel secrecy or transparency? Will it reduce us or expand us? These are not scientific questions, they are civilizational ones, and Atlas in its silence and myths has already forced us to begin answering them. As the comet faded into the distance, trailing dust into the black, humanity was left not only with spectra and orbits, but with an unfinished story. A story that points forward into uncertainty, into the inevitability of the next messenger. And so we step into that uncertainty, knowing that the galaxy is not silent, that silence is our own creation, and that the stars will keep sending us questions until we are ready to answer them. History often hides its turning points in plain sight. In the moment, events feel ordinary, confusing, fragmented. Only in hindsight do they take on weight, revealing themselves as hinges upon which eras turn. The story of Three-Eye Atlas may one day be remembered as one such hinge. Not because it revealed aliens, not because it shattered physics, but because it forced us to confront our silence, our myths, and our place in the cosmos. Imagine a historian a century from now, writing about the early 21st century. They would see our age not as we see it, but as part of a broader arc, the age when humanity first recognized the galaxy's debris drifting past us. They would note the discovery of Oumuamua in 2017, Borisov in 2019, Atlas in 2025. Three visitors, three markers in history, each one sharpening the realization that interstellar space is not empty. They would see in Atlas not just a comet, but a cultural experiment, a test we failed and passed at the same time. Failed because our institutions faltered. A government shutdown muted one of the most extraordinary events of the decade. Scientists were silenced, not by choice, but by policy. The absence of information allowed myths to bloom unchecked. Public trust eroded further, widening a fracture that already scarred the relationship between knowledge and belief. In this sense, Atlas was a failure of readiness, a reminder of how easily silence breeds suspicion. But also passed, because the data survived. Despite silence, telescopes recorded photons, spacecraft logged spectra, observatories preserved images. Even as myths spread, science endured. The comet was studied, measured and modeled. And in that persistence lies resilience. Humanity stumbled but did not fall, and future generations may look back on Atlas not as a scandal, but as a spark, the moment when the urgency of readiness crystallized, the moment when we realized we must do better. Consider how past generations misread their own turning points. When Galileo first pointed his telescope at Jupiter and saw its moons, many dismissed the discovery, clinging to the old belief in Earth's centrality. When fossils revealed deep time, people resisted, unable to reconcile them with scripture. When electricity was first harnessed, it seemed a curiosity, not the force that would reshape civilization. The great changes of history rarely announce themselves with clarity. They whisper. They pass by like comets in the night, their meaning only recognized later. Atlas may be one of those whispers. Not because it was alien, but because it was interstellar. Not because it changed science overnight, but because it forced humanity to see the fragility of its systems. It showed us that silence is not neutral. It is dangerous. It showed us that myths can overtake facts in the absence of transparency. And it showed us that even ordinary fragments from the stars can carry extraordinary weight if we are wise enough to listen. Future generations may also see Atlas as the beginning of a new kind of archaeology, galactic archaeology. For the first time, we are not confined to studying the chemistry of our own solar system. We are collecting fragments from other suns, relics of planetary systems far away. Each interstellar comet is a shard of a larger story, a galaxy in motion, a cosmos scattering its ruins across the void. To study them is to study history on the grandest scale imaginable. And Atlas, as the third visitor, may be remembered as the comet that solidified that realization. But perhaps the greatest legacy of Atlas will not be scientific or political at all. It will be symbolic. It will be remembered as the comet of silence, the one that revealed how fragile our relationship with knowledge truly is. The one that showed how easily absence becomes myth, how quickly trust can fracture, how ready we are to imagine both wonders and horrors in the dark. That symbolism will linger, shaping how we prepare for the next visitor. Because when the next one comes, and it will, our memory of Atlas will still be fresh. Think of how children in the future might learn this story, not as a footnote but as a parable about silence and suspicion, about wonder and myth, about the dangers of delay. They may be taught that Atlas was the moment humanity realized it must always be ready to speak, to share, to respond. That in a universe where fragments from other stars sweep past without warning, silence is no longer an option. And beyond children, beyond classrooms, consider how civilizations themselves will retell this moment. The discovery of interstellar travelers will one day be seen as the dawn of a new era. An era when humanity stopped seeing the stars as distant points of light and began to see them as connected, as sources of fragments that reach us. Atlas will be remembered as part of that dawn. Its silence will be a cautionary tale, its myths a reminder, its data a foundation. There is a kind of poetry in this. A comet from another star passed us by, carrying within it the ruins of a distant world, perhaps the metals of a broken planet. And instead of clarity, it gave us silence. Instead of certainty, it gave us myth. And yet in that paradox lies the essence of history itself. We do not always understand turning points when they arrive. We only understand them when they are gone. Atlas has already faded now, receding into the outer darkness, its coma shrinking, its light dimming. But the memory of it remains, not just in data archives, but in cultural memory. And one day, when the next messenger arrives, We will recall Atlas, we will recall the silence, and we will decide perhaps differently how to respond. The long arc of history is not built on clarity. It is built on whispers, on fleeting moments, on fragments of dust drifting through space. Atlas was one such fragment. Its true weight may not be felt in our generation, but in the generations to come, when the question of readiness becomes the question of survival. And so we step into that future, carrying with us the memory of silence and the knowledge that the stars are not still. They are always sending us pieces of themselves. The only question is whether we will hear them, or whether we will drown them in our own silence again. If Atlas reminded us of anything, it was this: the galaxy is not static. It is restless. It is a sea in constant motion, scattering fragments from one star to another, carrying whispers of worlds long gone across the vastness of space. When we detect an interstellar visitor, we are not just seeing an object, we are glimpsing the great circulation of the galaxy itself. Creation, destruction, scattering, drift. A cycle billions of years old, and one we are only beginning to understand. Consider what Atlas may truly represent. If its metals were indeed more abundant than expected, that is not just chemistry, it is history. Metals are forged in the hearts of stars, in supernovae, in kilonovae, where neutron stars collide. They are spread across the galaxy in waves of fire, seeding nebulae with the ingredients for planets. When a star forms, its planets inherit those elements. Some worlds grow rich in iron, nickel, and cobalt. Some remain dominated by ice and gas. And when those worlds are destroyed by collisions, by gravitational chaos, by stellar death, their fragments are cast outward. Atlas was one of those fragments. To study it is to study not just a comet, but the echoes of cataclysm. This is the galactic cycle. Stars are born, planets form, collisions shatter, debris is ejected. Some of that debris is trapped in new systems, sculpted into belts and clouds, but some escapes, flung free into interstellar space. For millions, even billions of years, it wanders the void until chance brings it near another star, near us. And for a fleeting moment, we glimpse it, measure it, wonder about it, before it continues on its way. Atlas was not just a comet. It was a relic of a star's ancient story, carrying within it the memory of a planetary system we will never see. But here is where the perspective deepens. If fragments wander between stars, then the galaxy is not isolated systems separated by emptiness. It is an ecosystem, a constant exchange. Every star contributes to the dust and debris of the galactic sea, and every star receives fragments in return, which means our solar system too is not purely ours. It is already seeded with the remnants of others. Interstellar grains have fallen into our atmosphere. Interstellar comets have brushed past our planets. We are part of a circulation far older and grander than we ever imagined. This realization changes everything. It means that when we look at Atlas, we are not outsiders peering at a foreign object. We are participants in a galactic conversation written in dust and stone. The galaxy is speaking constantly through the exchange of fragments. The silence was never in the cosmos. It was in us, in our institutions, in our inability to hear. Think of the implications for life. If rocks and dust can travel between stars, then so can the seeds of biology. Microbes embedded in frozen fragments could, in principle, survive journeys across interstellar space. This is the concept of panspermia, life scattering like pollen across the galaxy, hitching rides on comets and asteroids. We do not know if Atlas carried such seeds, but its very existence makes the idea plausible. If fragments like it are common, then the galaxy may be alive in ways we cannot yet measure, exchanging not just dust but possibilities of life itself. And if life can scatter, then intelligence too may leave traces. Not just radio signals, not just beacons, but artifacts, fragments of technology, probes abandoned, derelicts lost in the drift. Atlas may have been natural, but its passage forces us to ask, how would we know if the next one were not? Would we see it as part of the galactic cycle of debris, or as a deliberate message written in metal and motion? The cycle of creation and destruction does not answer these questions, but it sharpens them. Because what Atlas showed us is that interstellar visitors are not rare curiosities. They are inevitable consequences of galactic dynamics. Every collision, every planetary death, every stellar explosion contributes to the interstellar stream. Somewhere in that stream, perhaps, are fragments not of shattered planets, but of civilizations. Perhaps relics drift among the debris, waiting to be recognized. This is why Atlas matters beyond its science. It is not just a comet. It is evidence that the galaxy delivers to us pieces of its story. Every interstellar visitor is a chapter, drifting past for only a moment, then gone. To miss them is to miss the narrative of the stars. And Atlas, in its silence and myths, was the chapter that taught us that we must learn to read quickly or risk losing the story forever. From this perspective, the silence of October 2025 becomes even more poignant. For a brief moment, the galaxy handed us a fragment of its endless cycle. And we hesitated. We silenced ourselves. We drowned that gift in politics and myth. But the fragment did not wait. It passed us by, continuing its journey, carrying its secrets away into the dark. How many more will pass before we are ready to listen? Yet there is hope in this cycle too, because just as fragments leave, fragments arrive. The same currents that carried Atlas to us will carry others. There will always be another chance. The galaxy is generous, if patient. It has scattered its stories across billions of years, and it will continue to do so long after we are gone. Our task is to decide whether we will rise to meet them or let them pass in silence. And in this larger cycle lies a humbling truth. We too will one day scatter. The sun will not burn forever. Our planets will not endure eternally. One day, the Earth itself may shatter, its pieces flung into interstellar space. Our atoms will join the galactic sea. Perhaps fragments of our world will pass near another star, and another civilization will look upon them as we look upon Atlas. Perhaps they too will wonder about us. Perhaps they will build myths in the silence we leave behind. This is the cycle Atlas revealed, not just astronomy but destiny. We are participants in the galaxy's endless exchange of fragments. We inherit and we will give. We are not separate from the stars. We are part of their circulation, their scattering, their silence. The story of Atlas, then, is not only about what it was, but about what it reminded us. That the galaxy is alive with motion, that silence is ours to break, and that fragments are the language of the stars. And so as Atlas faded, it left us not just with data, not just with myths, but with perspective. Perspective that stretches beyond politics and science, beyond silence and suspicion, into the deep time of the cosmos. A perspective that says, you are part of this cycle. You are not alone, you are fragments too. If the galaxy is in constant motion, scattering fragments between stars, then the message of 3i Atlas is clear. Readiness is not optional. Visitors will come again. Some will be icy, some metallic, some ordinary, some strange. Each one will carry secrets of worlds we may never otherwise know, and each one will pass quickly, offering only a narrow window of opportunity. The lesson of Atlas is that silence and hesitation cost us dearly. The responsibility of the future is to make sure we are never caught unprepared again. Already the seeds of preparation are being planted. Space agencies, research institutes, even private companies have begun sketching designs for missions that could intercept the next interstellar object. Concepts like fast response spacecraft, held in readiness until a target is found, are no longer fantasy. Ideas of modular probes, launched in pieces and assembled in orbit for rapid pursuit, are gaining traction. Engineers imagine fleets of small, agile spacecraft, swarms that could fan out around a target, capturing images, spectra, and samples before it disappears into the dark. The technological challenge is immense. To chase an object like Atlas, moving at tens of kilometers per second, requires speeds beyond most of our current missions. Traditional chemical rockets are too slow. Instead, new propulsion systems must be considered. Solar sails, pushed by the momentum of light, nuclear thermal engines, heating propellant with atomic fire, even speculative fusion drives, harvesting the energy of the stars themselves. Each idea carries risks, costs, and timelines, but the urgency of Atlas gives them new momentum. The question is no longer whether such systems are worth developing. The question is whether we can afford not to. Yet readiness is more than engines and designs. It is also infrastructure. When Atlas appeared, much of the data bottleneck came not from telescopes failing, but from communication systems silenced by bureaucracy. In the future, readiness must include systems that bypass such fragility. International collaborations that guarantee data sharing across borders. Automated pipelines that release calibrated observations in real time. Networks that cannot be silenced by a single government shutdown. If the galaxy does not wait, neither should our flow of information. But readiness must also be philosophical. Atlas showed us how unprepared we are to face ambiguity. Faced with silence, we spun myths. Faced with partial data, we fractured into suspicion. If the next visitor defies explanation, will we fracture again? Or will we hold our collective breath long enough to listen, to study, to endure mystery without rushing to conspiracy? To be ready for interstellar messengers is to prepare not only our rockets, but our minds. This is where the responsibility deepens. We cannot meet the next visitor only as consumers of spectacle. We must meet it as participants in discovery. That means cultivating public trust, strengthening science communication, and building a culture that values patience as much as revelation. It means acknowledging uncertainty without allowing it to collapse into chaos. It means remembering that silence is not always evidence of secrecy. It can be the space science needs to work. If we fail in this cultural preparation, then no amount of technology will save us from repeating the mistakes of Atlas. There is also an ethical dimension. Suppose we are able not just to intercept a future visitor, but to sample it. Suppose we can bring back fragments of interstellar material, shards of another star's history. How should we treat them? Are they curiosities, trophies, resources? Or are they sacred relics of the galaxy's story? These questions will matter because the drive to exploit will come quickly. Mining companies already speak of asteroids as future quarries. What happens when an interstellar body, rich in metals or volatiles, enters our path? Will we study it with reverence or strip it for gain? The legacy of Atlas suggests we must tread carefully, balancing curiosity with responsibility. And beyond ethics lies philosophy. Each interstellar visitor is not just an object but a reminder. We are part of a galaxy in motion. We are fragments too, destined one day to scatter into the dark. Readiness is not just about seizing opportunities, it is about understanding ourselves. To prepare for the next messenger is to prepare for the truth that we are not central, not fixed, not eternal. We are participants in a cycle larger than our species, larger than our star. That humility may be the most important preparation of all. Still, even humility must act. For if Atlas taught us anything, it is that opportunities vanish quickly. In the weeks of silence, the comet swept past Mars and out toward the sun. By the time voices returned, much of the moment was lost. That loss cannot be repeated. Future readiness must be relentless. Instruments must be primed. Missions must be funded. Protocols must be written. And above all, silence must never again be allowed to dominate the story. The responsibility is heavy, but it is also exhilarating. For the first time in history, humanity knows with certainty that fragments from other stars pass through our sky. That knowledge is a gift, a reminder that we do not have to wait centuries for interstellar contact. The galaxy is coming to us piece by piece, comet by comet. We have only to be ready to catch it. And readiness will change us. It will drive new technologies, accelerate new philosophies, and perhaps unite us in ways nothing else could. Because when the next messenger arrives, it will not belong to one nation, one agency, or one people. It will belong to all of us as part of the shared story of the galaxy. Our response will be a measure of who we are, not just as scientists, not just as governments, but as a civilization. So we must ask ourselves now in the quiet after Atlas, are we building that readiness? Are we investing in the engines, the instruments, the cultures we need? Or are we waiting, complacent, hoping that the galaxy will wait for us? It will not. The stars do not pause, the fragments will keep coming, and we, if we fail, will keep losing them. This is the responsibility Atlas left us with. To be silent no longer. To prepare with urgency. To meet the next messenger not with hesitation, but with open hands and open eyes. Because the future is not about whether interstellar visitors will come. They will. The future is about what we do when they arrive. There is a haunting symmetry in the story of interstellar visitors. They come to us as fragments, shards of worlds destroyed, whispers of systems we will never see. And in them, we glimpse not only their past, but our future. Because one day, we too will scatter. The earth will not endure forever. The sun will swell, the planets will shift, and the relics of our world will drift outward, carried into the galactic sea. Atlas, in its silence, forced us to see that truth. We are not only observers of the cycle, we are destined participants. This realization transforms how we think about our place in the universe. For centuries, humans imagined themselves as fixed at the center of creation. Later, we accepted we were one planet among many, one star among billions. But now we must accept something deeper. We are fragments in waiting. The galaxy is not a backdrop to our story. It is the context that will one day carry our ashes. The stones of Earth, the bones of our species, the echoes of our machines. One day, they will become someone else's Atlas, someone else's mystery, someone else's myth. What would they think of us? Imagine another civilization, centuries or millennia from now, detecting a faint object on a hyperbolic path. They point their instruments, record spectra, and see metals, volatiles, strange ratios. They debate whether it is natural or artificial, whisper about fragments of a world long gone. They wonder about silence, about myths, about who we were. To them, we would be what Atlas was to us, a riddle in the dark, a shard of history without context, a story half told. This possibility humbles us. It reminds us that we too are temporary. Our cities, our nations, our debates about silence, all will vanish. What remains will be fragments, perhaps an alloy plate from a satellite, perhaps a grain of glass forged in nuclear fire, perhaps the frozen remains of a spacecraft drifting between stars. And as those fragments travel, they will carry with them the only trace of our existence. Will they be enough? Will they speak clearly, or only whisper? Here lies the existential weight of Atlas. It showed us what it feels like to stand on the receiving end of such a whisper. We saw an object cross our sky, knowing it came from a world we will never visit, a star we may never map. We argued about what it was, what it meant, what it carried. And perhaps that is exactly what others will do with us. The cycle does not end with observation, it ends with reflection. We are not only students of fragments, we are fragments ourselves. This changes the way we must approach our own legacy. For if we are destined to scatter, then perhaps we must choose what story our fragments will tell. Will we let chance decide, leaving only broken remnants, misunderstood and forgotten? Or will we write intentionally, embedding our story in artifacts designed to endure? Some already dream of this. Interstellar archives, messages encoded in metals, probes launched not to communicate immediately, but to drift for eons until they are found. The Voyager records were the first attempt, golden discs carrying songs and images into the dark. But they are only the beginning. If Atlas taught us the power of fragments, perhaps we must become deliberate about the fragments we leave behind. But even as we think of our legacy, we must confront another possibility, that others have already done the same, that among the countless interstellar bodies drifting through the galaxy, some are not just shards of planets, but messages. That Atlas itself could have been one, and we failed to recognize it. This is the unsettling thought, the idea that the galaxy may already be full of stories, and we are too deaf, too slow, or too silent to hear them. The silence of 2025 becomes even more poignant in this light. What if Atlas carried more than we realized? What if its fragments, its dust, its metals held secrets we ignored? What if the myths, though unfounded, were closer to truth than the data allowed us to admit? We may never know. Atlas is gone, fading into interstellar night, its secrets carried beyond reach. But the question lingers like a ghost. What did we miss in our silence? And yet, perhaps that is the point. The cosmos does not hand us certainty. It hands us riddles. Each visitor is not an answer, but a question, asking, will you listen? Will you prepare? Will you learn? Atlas's question was one of silence, of patience, of readiness. Perhaps the next visitor's question will be different, one of clarity, one of proof, one of undeniable presence. We cannot control when that moment comes. We can only control how ready we are to face it. In the end, the existential truth is this: interstellar visitors are reminders of mortality, not just our mortality as individuals, but our mortality as a species, as a world, as a system. They remind us that stars die, planets shatter, civilizations vanish. And yet in that vanishing there is continuity. Fragments survive, stories survive, silence is never absolute. The galaxy remembers, even if imperfectly. Atlas remembered its star, its parent world, its destruction. We read that memory in metals and dust. One day someone will read ours, This perspective is sobering but also liberating. It frees us from the illusion of permanence. It tells us that our task is not to endure forever, but to write meaning into the fragments we leave behind, to ensure that when we scatter, our story is worth finding. Atlas forced us to face this truth, not by what it was, but by what it reminded us we will become. So the question deepens. If we are destined to be fragments, what story do we wish to tell? Will it be a story of silence and suspicion, or a story of wonder and readiness? Will it be a myth born of absence, or a legacy chosen with intention? The answer is not written in the stars, it is written here now in how we respond to the messengers that pass us by. Atlas is gone, but the silence it carried remains. And in that silence, the galaxy waits, not for words, but for our choice. In the end, the story of Three-Eye Atlas is not only about a comet, it is about silence, myth, and memory. It is about what happens when a fragment from the stars brushes past our world and finds us unprepared, not technologically but psychologically. It is about the tension between science and speculation, between patience and paranoia, between what the cosmos gives us and what we make of it. Atlas came and went in a season. A faint streak of light, brighter near Mars, active near the Sun, fading back into darkness. For astronomers, it was a data point, the third interstellar visitor ever recorded. For scientists, it was a puzzle of metals and brightness, of ratios and models. But for the world, it became something more. Silence gave it weight. Absence gave it myth. For a brief moment, Atlas was not just a comet, it was a mirror, showing us the fractures and longings of our own civilization. We learned that science cannot speak if systems fall silent, that transparency is fragile, easily broken by politics, that myths bloom quickly when trust is thin. We saw how absence became louder than data, how the ordinary was made extraordinary by nothing more than delay. And we saw too how hungry we are for meaning, how quickly we leap from metals to messages, from tumbling rotation to intention. Atlas revealed the fragility not of the cosmos, but of us. And yet, within that fragility lies possibility. For Atlas did not pass in vain. It sparked a reckoning. It awakened urgency. It reminded us that interstellar visitors will not wait for us, that readiness must be constant, that silence must never again be our only answer. It seeded conversations about missions, about propulsion, about archives of meaning to leave behind. It pushed us to see the galaxy not as distant, but as participatory, a cycle of fragments in which we are already embedded. Perhaps that is the truest legacy of Atlas. Not that it was extraordinary in itself, but that it forced us to recognize the extraordinariness of the ordinary. A comet, natural and fleeting, became legend not because of what it was, but because of what we made of it. And in that legend lies a lesson. We are not passive observers of the cosmos. We are interpreters, storytellers, myth makers. The stars send us fragments, and we turn them into meaning. That is our gift and our burden. But Atlas also leaves us with a question, one that lingers long after its dust has vanished from our sky. What will we do when the next visitor comes? Will we repeat the mistakes of silence, drowning wonder in bureaucracy and myth? Or will we rise to the challenge, ready to speak, ready to listen, ready to meet the messenger as it deserves? The cosmos is not silent. It is alive with motion, scattering pieces of itself across the dark. Each visitor is a reminder that the galaxy is a web of stories, and that we are part of it. One day, our fragments will join that web. One day, someone else will look at a piece of us drifting past and wonder who we were. The story we tell of Atlas is the story they may one day tell of us. So let us not meet the next messenger with silence. Let us meet it with openness, with readiness, with humility. Let us remember that each fragment is both question and answer, both relic and promise. Atlas asked us who we are when faced with uncertainty. The answer we gave was flawed, fractured, unfinished, but the next chance will come. The galaxy will see to that, and when it does, perhaps we will be ready. Perhaps we will finally hear the language of the stars, not as silence, not as myth, but as truth. Until then, Atlas drifts on, outward into the night, carrying with it the memory of a world we will never see, and the reflection of our own. A messenger not of aliens or omens, but of us, reminding us that in the vastness of the cosmos, the greatest silence is not out there. It is the one we create here.